My name is Eugenia and I'm a math tutor. Today we're going to learn how to use limits to find the slope of a tangent. The slope of a tangent line at a point x can be found by using the following limit. The limit as h tends to 0 of the function of x plus h minus f of x all divided by h. This is basically the limit definition of a derivative. So let's do an example and see how we use it. Suppose we need to find the slope of a tangent line at a point x on the function 2x squared plus 6. We begin by writing our limit definition again and filling in the functions as we go. So we have the limit as h tends to 0 of f of x plus h. So here we'll have 2x plus h squared plus 6 minus f of x, so this is just 2x squared plus 6, all divided by h. Our next step is to go ahead and expand this x plus h squared, which will be x squared plus 2xh plus h squared, and multiply it by the 2, which will then allow us to combine like terms. So we have the limit as h tends to 0 of 2x squared plus 4xh plus 2h squared, and then we have our remaining plus 6 minus 2x squared plus 6, and all divided by h. Now this looks like a long mess, but a lot of these cancel out. We have 2x squared minus 2x squared, so both of those cancel. And then we have plus 6 and minus 6, so both of those cancel out. That leaves us with the limit as h tends to 0 of 4xh plus 2h squared, all divided by h. Our last step is to go ahead and factor one of these h's out of the numerator, and then it'll cancel with the bottom. So we'll get rid of those and the squared there, and we have the limit as h tends to 0 of 4x plus 2h divided by 1. Now we can go ahead and evaluate our limit, since this won't be indeterminate as there's only one h in the top. So if we go ahead and plug 0 in for h, we'll just get 4x plus 0 over 1, or just 4x. And that's our limit. So 4x is the slope of our tangent line at any point x on this function. And that's how we find the slope of a tangent by taking the limit. Thanks for watching.